link to this SDRSharp Gpredict satellite tracking plugin, that is this link, was shared by YG4SLJ. The program or the plugin is by Alex, and it is you have to simply download the zip file and move the DLL file into SDRSharp folder. Then add a magic line which will be described in the page by Alex. Then in Gpredict, add radio interface from preferences and then use radio connect interface to connect the plugin. That's what has been described. This is the phase of the Gpredict software. Now we'll go to that page, that is plugin page. This is the plugin page on GitHub by Alex. And I'll scroll down. SDRSharp Gpredict connector. Plugin to connect Gpredict to SDRSharp. And latest compiled version is available on this link. Installers just copy the sdrsharp.gpredict connector.dll into your SDRSharp directory and add the magic line to your plugins.html file. This can be copied using this link. The line can be seen in full here. The code which has to be added to the plugins file. I'll go to the downloads. This is the I have the SDRSharp Gpredict connector version 3 zip, that is in August 2018. That is the latest. I download that. That has been downloaded. I will minimize this window and then bring the SDRSharp folder here. I opened it. This is a zip file. I unzip it. You can see that this is the DLL file and I have to copy to the SDRSharp folder. This is the SDRSharp folder. I'll just copy it over there. It has come here. SDRSharp folder is a folder from which I'll run the RTL-SDR using this SDRSharp.net8.exe. And now I'll have to look for the plugin.exe. Sorry, plugin.xml file. It's not here. Let me see once again. AirSpy. It's not there. Plugins.xml is not here. I'll see whether it is there inside this. This folder is also empty. As you have seen, I could not find any plugin.xml file. The plugins folder was empty. So after a lot of online search, I found a method and I'm going to try that out. I'll create a new text document, open that. An online code, I found this to create the plugin. And this should be the magic line which Alex has described. And this has been opened in a text document. I have created a new text document, and in that I found this in a forum, and this is the probably the magic line which Alex has mentioned. And I'll save this as in the SDRSharp folder as plugin.xml. And I'll close it, and I'll minimize this and see. Now a plugin.xml has come here. I'll open again with in Notepad, and that data is there. So a plugin.xml file has come. Now the other steps I'll have to go back again. I'm going to open the Gpredict. This is the Gpredict amateur module, and now I'll have to edit the preferences. In the preferences interfaces, I have created this one. You can create a new one like this. Add new. You have to give the name here. I have given the name RTL-SDR, and since it is RX only, receive only, the default RX only has been taken, and I had clicked OK. And this is what I have. RTL-SDR localhost port. And OK. After that, I have to configure the radio control. In the radio control, this is a radio control, Gpredict radio control amateur. This I had already configured, but now it has gone back to AO91. I'll choose once again ISS, and in ISS default what comes is VAPRS, that is VHF APRS. You can see the APRS frequency here, 145.25. That is the APRS frequency. This is uplink, this is downlink. And I will change this mode to find the voice mode. Mode VU FM voice repeater. When I change to that mode, I can see that the usual downlink frequency has come here, 437.800, and Doppler tracking is going on here, and the mode has come here, name of satellite ISS, and the azimuth elevation, everything is there. It is minus. Elevation is negative, means satellite is not in range, and distance of the satellite is too much, as the acquisition of signal will be only in 35 minutes. And RTL-SDR is shown. Uplink frequency also is being shown here. But there is no question of uplink for RTL-SDR, it's only downlink. Now I'll stop here and wait for the time when the space station comes in range in another 35 minutes. This is how I have connected RTL-SDR block model V4 to the laptop through the USB port, and an SMA F2 SO239 patch cable which goes to the PL259 of the RG216, which is the antenna cable. This is my 80-meter inverted V dipole antenna. Now I'll open the software SDRSharp.net 8.exe. AirSpy is the software. I'll resize the window because it has gone beyond the view. Now I'll have to take the source. Source is RTL-SDR USB. Wideband FM. No squelch. I'll open up. I'll just reduce the volume. This is the place where you will see the Doppler shift of the space station signal. This is the Gpredict. It's now tracking AO 91. RTL-SDR. In the radio control. This is the radio control. It is showing as AOS in 5 or 6 minutes. I have minimized the main Gpredict window so that I can see this. I am repositioning it so that I can see this Gpredict window as well as the AirSpy window and see whether actual radio control is happening when the satellite comes in range. I have to do that again. Mode VU FM voice repeater. So what I was seeing earlier was AO91 and not ISS voice repeater. Now it has come 437.800 downlink, 145.890 uplink. Sorry, 145.990 uplink. That's what is being shown here. I'll have to wait nearly 20 minutes. While waiting for the next pass of International Space Station in another 13 minutes or so, we learned something about ISS. I have just clicked here and chosen this satellite as ISS. Earlier it was displayed as AO91 and the current azimuth and elevation are given. Elevation is still negative, meaning that the satellite is still below the horizon. There's about 13 minutes to go, and the slant range is shown, and next event AOS time is also given. That is the next AOS, and the footprint of the satellite, the maximum range from which you can access the satellite, and altitude of the satellite is 432 kilometer. The velocity, it's traveling at a very fast velocity, 7.651 kilometer per second, and the Doppler shift is shown. Signal loss, signal delay, all those are shown. Just learning a little bit about the ISS. This is where the ISS is shown with respect to my region. It is here. It will gradually approach my region, and the footprint is also shown here graphically. You can see that this is the RS-44 satellite, which is at a higher altitude. You can see RS-44 has much more footprint because it's at a higher location. The footprint is much more. I'll choose RS-44 and show the altitude. I have chosen RS-44 here, and you can see that the footprint is much larger, 7,907 kilometer, and the altitude is very much more than that of space station, 1,457 kilometer. That's why it has a large footprint. I'll go back to the display for. We have a pass at 5 o'clock here. Before I go, I can notice this. And I'll go back to ISS. Now the space station pass is due in my region, and in another 30 seconds, you can see that it has come near my home. You can see it's almost getting into the footprint. My home is here, and the footprint is just about near that. And in another 14 seconds, you will have it rising above the horizon. Let us see. 5 seconds, 4 seconds, 3 seconds, 2 seconds, 1 second. Now it should be just above the horizon. You can see it here. I'll move this up and show a bit. You can see the spot has come here. ISS is there on the polar map. And azimuth and elevation are being displayed here. I'll see what's happening with the radio control. Loss of signal. Now it should be acquisition of signal, and loss of signal means satellite is setting in another 10 minutes. The Doppler shift needed here is 10 kilohertz for downlink and about 3.3 kilohertz for uplink. But somehow I cannot see that change here. The RTL-SDR spy software has not shown that. So maybe the radio control is not functioning well. That I'll have to check once again. There might be some error in the plug-in connection. I'll have to troubleshoot that. Anyway, I can see the polar map now in Gpredict, and I'll minimize this window because that's not functioning well. I'll now increase the audio. Audio heard was the open squelch, nothing else. We'll monitor the satellite path. Elevation is now 11 degrees. Remember that I am using an 80-meter dipole, so I don't expect great results here. Next time I'll use another antenna, CP22A antenna, and still later I'll try Moxon Yagi. For this pass, I'm going to try with 80-meter antenna only, because the inputs of the antennas are at different locations, so I can't just immediately shift to that antenna. What I can do is I can shift to 40-meter to 10-meter fan dipole, but not to the VHF antennas, because they are in different location. This is the place where I'll see the waterfall display. This is not the waterfall display. This is just a marker signal. Elevation is 22.23 degrees. So I should be hearing something. Last time I could see the waterfall display here, but this time I'm not seeing that. My radio control has not worked yet. It is nice to see this icon of International Space Station moving on the polar map live. You can see that I am very well in the footprint now. Now I just changed over to the 80, so from the 80-meter dipole to 40 10-meter fan dipole. Still I can't see anything. Satellite is now beyond the point of maximum elevation. The elevation is only 28 now. It has gone up to 58 or so. This mission has only been partly successful. I've been able to watch the ISS pass on the Gpredict window, while I have not been able to get the signals on the RTL-SDR. Earlier I have obtained signals on a lower elevation pass, so this is something to do with probably the radio control which has not worked. I'll have to rectify that. I'm stopping now because already the satellite is going down, and as I have not heard during the maximum elevation, there is no point in trying further. I'll have to rectify the problem.